Everyone, we're going to start our 3.6 lesson where we're doing more equations with grouping symbols and just kind of adding on to what we had started on Friday, just adding one step to those same kinds of equations. Now, one thing I'll mention just right off the bat here, make sure you stay till the end of the video as there's going to be a grade boosting opportunity I'll talk about at the end of the video that'll allow you to get some extra credit. So make sure you stick around to the very end. All right. Well, here we go. We can just jump right into it. Again, there's nothing entirely new besides we have operations outside what I'm going to refer to as the function operation. So function operation kind of being either the parentheses, but definitely the absolute value and the squaring, and then we get to the exponential. So one thing that we're going to work to do today is we're going to undo operations that are happening to these terms that we're trying to isolate. So here we're trying to isolate this linear term. In 2, we're trying to isolate the absolute value term. And 3, we're trying to isolate the quadratic term. Now, some of you might be looking at 1, you're like, can't we distribute? And the answer is yes. We can take that 4 and multiply it to the x and the -2, but I actually don't want us doing that yet. We're going to have a whole lesson where we start to distribute. The reason I don't want us to is we can only distribute if we're working with something that is linear. You cannot distribute inside these absolute value brackets, and we can't distribute inside of this quadratic, and it all has to do with PEMDAS, okay? So this 4 that we see on the outside of all 3 of these, it wants to multiply. So our first step in these, in order to isolate the function term, is to divide by 4 and undo that wantingness to multiply by 4. So multiplying by 4, dividing by 4 cancel, and I get x minus 2 equals 4. Once we divide by 4, or excuse me, I guess I can keep the parentheses there, they actually don't matter, and we don't have anything else to do to remove these parentheses, right? There's no squaring, there's no absolute value bracket. So for number 1 here, the last thing we need to do is just add 2 to both sides. That gets rid of the minusing 2, and x is equal to 6. Okay, so not a lot when it's a linear equation. Now for number 2, we divide by 4 to again undo the multiplying of 4. That brings us to the absolute value of x plus 3, and it equals 16 divided by 4, which is 4. So just like what we talked about on Friday, we know that whatever we take the absolute value of, so whatever's inside the absolute value of x plus 3, that needs to equal 4, and it also needs to equal -4. So what's inside those absolute value brackets now is the x plus 3. So once we isolate the absolute value term, that's when we can go ahead and deal with the absolute value, which has us splitting it up and setting x plus 3 equal to 4 and a -4. Now to finish this equation, we need to subtract 3. I get x equals 1. Subtract 3 and x equals -7. All right, well, same idea to get started for this number 3 where we have a quadratic term. Again, we can't square root right now because of this 4. Remember, we're working to undo operations in the reverse order of PEMDAS. So we need to undo this multiplication before we can undo the exponent that's happening there. So dividing by 4 gets rid of the multiplying by 4, bring us to 2 minus x squared equals 4. Well, this is where we can go ahead and take the square root because we've now undone the multiplication. Now we're up to undoing the exponent, which is having us square it or square root it. That gets rid of the squaring. And so we have 2 minus x equals plus or minus 4, or 2 minus x equals 4, and 2 minus x equals -4. Now that we've split it up and set it equal to our 2 solutions, we have 2 equations to solve here, where we're going to start by subtracting 2. That gets rid of the adding of 2. So I have -x equals 2. And divide by -1. That gets rid of the multiplying by -1. And x equals -2. Okay, to finish the other equation, I've already identified that I need to subtract 2. And so I get -x equals -6. Then dividing by -1 gets us to x equals +6. Okay, so that's really the only thing that we're adding to this is now Again, we need to isolate the term that has grouping symbols or an exponent. And again, the reading out loud can kind of help with this. So let's do these three together. Again, stick with the video as you're going to have an opportunity for extra credit at the end. All you need to do is stick around and you'll get some extra credit. So keep watching, keep taking notes. And for number 4, if I had to read that, that's 4 times 2 to the power of x minus 3, and it equals 16. Well, if we go in the reverse order of PEMDAS, okay, we need to undo this multiplying of 4 before we can undo or deal with the exponent there. So just like what we did with 1, 2, and 3, that 4 wants to multiply, we need to divide it. Dividing by 4 gets us to 2 to the power of x minus 3, and now it equals 4. Again, the parentheses don't really matter anymore. If you want to add them in, that's fine. But where we're at right now is we have to figure out 2 to what power is 4. Well, if we list our facts, 2 to the power of 0 is 1, 2 to the power of 1 is 2, and 2 to the power of 2 is 4. Okay, so what we need is this exponent of 2 to be equal to the exponent in our equation of x minus 3. So x minus 3 equals 2, and we add 3 and get x equals 5. All right, well, let's just keep going with this. We've got a few more that we're going to do, and then again, we'll get to the extra credit conversation here in just a second. So number 5, again, some of you might look at this and want to distribute. Absolutely okay, because it is linear, distributing is fine. We're going to have a whole, again, lesson where we're focusing on distributing. So for today, let's just undo this multiplying of 5, and that's what it means to distribute, by dividing by 5. Well, that's actually really nice because 0 divided by 5 is 0. So we get x plus 5 still equal to 0. All that we need to do to get x by itself is subtract 5. And I get x is equal to negative 5. Done. And again, if you distribute, you'd get the same answer. Okay, number 6. If I had to read it out loud, that's 5 times the absolute value of x minus 4 equals 5. Again, these absolute value brackets, they behave like parentheses, so they're the last thing that we're going to work to undo. So we have to undo this wanting this to multiply before we get there. So we're going to start by dividing by 5. And again, with absolute value, you cannot distribute inside those absolute value brackets anyway. So we need to do this division here. So that gets us to the absolute value of x minus 4 equals 5 divided by 5, which is 1. And now we need what's inside the absolute value brackets to equal positive 1 and negative 1. So we'll take that x minus 4, we'll write it twice because we know it needs to equal 1 and negative 1. Well, to solve both of these, we have one more step to take. That is to add 4. And so adding 4 to the 1 brings us to x equals 5. Adding 4 to the negative 1 gets us to x equals 3. Okay, once you have this written down, go and flip the page over. Again, we'll probably do just a couple more, and then we'll talk about the extra credit you're going to get today. So yeah, 7 and 8, and then we'll talk about what you need to do for 9, 10, 11, and 12. Okay, for 7, again, when I'm looking at this, I have 5 times 8 minus x squared equals 100. We have to undo this multiplying of 5, which will then isolate the squared term after that. So divide by 5. And that gets me to 8 minus x squared equals 20. Now we need to take the square root of both sides. So where 8 minus x equals plus or minus the square root of 20, which is not a whole number. And we can do one of two things. I think here, let's go ahead and get our answer into the decimal form. So remember on your calculators, after you square root 20, you have to press that button that has the arrows going in opposite directions to convert it to this decimal. And let's call it 4.47. So we're going to work with some decimals here, which is okay. And we have that 8 minus x needs to equal both positive 4.47 And 8 minus x needs to equal negative 4.47. Okay, so to do this, we've got two equations to solve, both of which will start by having us subtract 8 from both sides. You might need the calculator for that. In fact, I definitely do for this first one. So 4.47 minus 8, negative 3.53. And then we have that negative x will also equal negative 12.47 for the other equation. So then I want to divide both sides by negative 1. And that gets my answer over here. Negative divided by negative is a positive, so positive 3.53. Negative divided by negative is a positive, so we also get positive 12.47. And there we go. So don't shy away from those decimal answers. They're going to show up quite a bit. I want us to work on just getting a little more familiar with them. All right, we're almost done. We'll do number 8 and then talk about how you're going to earn extra credit today. So number 8, we need to divide by 5 to start. So undo the multiplying of 5 by dividing. So 9 to the power of x minus 2 equals 45 divided by 5, which is 9. So we need to list our exponential fact that'll help us work with that exponent there. So 9 to the power of 0 is 1. 9 to the power of 1 is 9. Ooh, that's that fact that helps us. Where we need our exponent of x minus 2 to equal 1. So x minus 2 equals 1. After I add 2, the x is equal to 3. All right, good. Okay, so we have 4 problems left. Because we do have the fraction here, and that actually gets asked about a lot, let's do number 9 together, and then again I'll talk about how you're going to get extra credit for 10, 11, and 12. So if I read this, that's x plus 7 divided by 2. Again, remember our task here is to go in the reverse order of PEMDAS. Oof. Now I say oof because this x plus 7 actually has an invisible set of parentheses, where the first thing that we need to do is actually get rid of the dividing by 2, which goes against our reverse order of PEMDAS because it feels like we should subtract this 7. But the problem is that 7 is divided by 2, making it not really a 7. So when we have these fractions, just pretend that there's parentheses around the top and the bottom. And now our idea of reversing PEMDAS works because this x plus 7 is in the parentheses, and that's the last thing that we'll deal with. Okay, so we'll do that. Actually, the other ones already have the grouping symbols set up for us. So kind of sneaky with that. All of that to say, for number 9, we need to start by multiplying by 2 to get rid of the dividing by 2. That makes us have x plus 7 is equal to 2 times 2, which is 4. All I need to do is subtract 7. I get x is equal to negative 3. Okay, so again, kind of tricky there, but when we have these fractions, we want to undo the division, which creates the fraction to start. Okay, so here's how you're going to earn extra credit. You are going to complete 10, 11, and 12 on your own or in your groups. I don't want you to tell anybody that's not watching this video that they need to work through these 3 to get extra credit. Keep this to yourself. Okay, if you're watching with a friend, then good job for making this far. What I'm going to do is give you 10 extra credit points just for working on 10, 11, and 12. What I'm going to do is just tell you what answers you should get. So to get the extra credit, all I need to see is you showing the work to work towards those answers. If the work's not right and you don't get to the answers, that's okay. Just attempting 10, 11, 12 will automatically get you extra credit for today's work. Okay, so what I'm going to do is pause my recording. I want you to pause the video as well. I want you to try to work out 10, 11, and 12. After I unpause and after you unpause, you'll see the answers at the end. And again, as long as you have work shown, whether it's right or wrong, you're going to get 10 extra credit points for making it this far in the video. So go ahead and hit pause and try to work through 10, 11, and 12. All right, hopefully you've worked out 10, 11, and 12. For 10, that ends up being no solution because you have an absolute value equal to a negative, so not a lot of work you need to show there. 11, there should be quite a bit of work that leads you to answers of 8 and 0. And then number 12, when you multiply by negative 32, now we're trying to get an exponent to equal a negative, which can't happen, so that is a no solution. So again, as long as you have work shown that leads you to these answers or different answers, I'm going to check this on Tuesday and you'll get extra credit. Again, don't share this with people that are not watching the video. If you've made it this far, congrats, and I'll reward you by giving you 10 extra credit points as long as you have work shown here. Go ahead and show the sub your completed notes, and now you can start on the homework. Have a great day.